Okay everyone, so welcome to lecture once again. Now in my previous lecture, as we were able to create a single agent, and we now know that how we can try to use a Euri API and its entire ecosystem to access the model or maybe to track the uses. So now it's time to create a multi-agent system. So multi-agent means multiple node. We are going to create a multiple smart node, I would say, which will be having a LLM access, and eventually all of these node will be able to take some sort of a decision. It is going to do some sort of a task automatically. That is something that we are going to discuss. So let me share my screen, and yeah, so let me create a new file, a LangGraph underscore multi agent.ipynb. Fine. Okay. So let's get started, and I'm going to select the same kernel. So the kernel which I was using, so where my Euri is installed and where my LangGraph is also installed. Now here, so what we can do, so we can start doing a particular task. Now, what is the task that I will be doing? So first of all, guys, try to do some sort of an import from Euri AI dot LangGraph, import basically Euri AI LangGraph. So this is the first import that you have to do, and execute. So yes, we are able to import it. It simply means that I will be able to create a graph instances. And then let's try to create a graph instance. So to create a graph instance with the help of Euri graph, so you have to give a API key. I believe we all know from where I can get the API key. Let me show you once again. So to get the API key, come over here and click on create API key, give a name, and then it will end up creating your API key. Simple, right? So very simple. We have done that hundreds of times. So just replace this API key with that one. Simple. If you have to change the model, so because we have a 25 plus model for a different purposes, you can change the model as well. So this is the entry point. This is the basically graph object that we are able to create for a LangGraph. Yeah, for the LangGraph with the help of Euri LangGraph SDK, or you can say a package. Now, what is next and what we are trying to achieve over here? So basically, here, so I will try to create a multiple node. Let me show you that part. First of all, in a theory, that what we will try to perform as a part of this whole example, and that will be very quick, by the way. So we are going to create a 4 node. The very first node is, let's suppose, a researcher node. Researcher node. The second node that we are going to create is maybe a synthesizer node. I can try to give any name that I want. Synthesizer node. The third node that we are going to create is classifier node. And the fourth node that I'm going to create is a finalizer node. Finalizer node. F-I-N-A. Yeah. Finalizer node. So these are the node. Node number 1, node number 2, let's suppose, node number 3, and node number 4. So these are the 4 different kind of a node I'm going to create. This node will do some task, this node will do some task, this node will do some task, and this node will do some task. So every node is going to do some sort of a specific task automatically. Yeah. And then obviously there will be an edge by which we are going to connect each and every node. There will be a edge, let's suppose 1, edge 2, edge 3. As of now, I'm just trying to give a symbolic name. And there will be maybe input. So there will be an entry point, right? So entry point, and then maybe a output point, right? So everyone is going to do a task in a sequence, and everyone must be aware about the task that they are doing and the task which has been done by other node. So basically, it's a stateful transaction that we are talking about over here, right? A stateful transaction. Now, some of the node can be a AI node, and some of the node can be a non-AI node. What is the meaning of AI node? AI node simply means that they are going to use a LLM directly, right? So here we are going to see even a AI node, and then non-AI node. Non-AI node means so maybe I'm going to write a certain function and they're going to call some sort of a functions, right? A static function or maybe some sort of a dynamic function. I'm going to call it eventually. So this is the kind of a graph that we are talking about. And with the help of this, we will try to solve a certain problem. For example, so if I'm going to give an input, right? So if I'm going to give an input saying that, okay, so just try to do one thing. If I'm going to ask a question, tell me about a generative AI or tell me about a LangGraph. So maybe it will go do a research. If there is an internal document, so from internal document, it will try to fit some sort of a data, and then finally it will send to the synthesizer. It will try to send to the classifier that, okay, fine. So this entire question falls under this particular category, and then it is going to finalize the result and give it to me, right? Give it to me. So there can be a infinite number of different things which I can do and I can try to process. But I will be picking up a very simple one. I'll be picking up the very simple one. So here, the flow which I would like to create is that we are going to create a little bit of flavor of RAG as well. So let's suppose here I have a file called as RAG underscore context.txt. So this is the file which I'm trying to keep, and inside this file, let's suppose I'm keeping some information about the LangGraph. That LangGraph is an open source Python framework for stateful transaction, composable and observable LLM workflow. So there are some detail which I have mentioned over here, right? So you can build a multi-agent pipeline with the memory, retrieval tools, streaming output. Euri AI integrates by powering each node with the real-time inferences using a model like GPT, basically GPT 4.1 nano. So this is the very small document which I'm trying to keep. Yeah, very small document I'm trying to keep. Now, so the flow which I'm trying to teach you over here, that whenever I'm going to ask a question, right? Whenever I'm going to ask a question, so first of all, it should go and it should basically check that, okay, so do we have some record which is available? Do we have some sort of a data internally which is available? I can add one txt file. Maybe I can try to add hundreds of PDF over here. That's completely fine. So first of all, it should go and check. For example, if I have to create a flow for this one, so whenever I'm going to ask a question, so means wherever there will be a input. Let's think in this way. Wherever there will be an input, so what it should do in a very first place, check INTER internal docs. Maybe docs are available into a PDF format, maybe into a TXT format. And if there is a data which is available inside this particular document, right? So this particular document, in that case, what it should do, so it should try to consider that particular data, right? It should try to consider that particular data, and it should try to summarize those data, basically, right? It should summarize those data and then pass it on to the next node, that, okay, I have certain information which is available even internally. So that I'm not I'll not go and I'll just try to rely on a LLM. This is what I'm trying to say. Yeah, this is what I'm trying to say. So let me do that part first in terms of code. So here, first of all, what we will do, so we can try to write a function, external function, by the way. So maybe I can try to give a name as a def researcher node function. Yeah, function. Now what it will take, so it will take, let's suppose, a state as an input. So here state, and it is going to take input, let's suppose input input, state of input, and this I'm going to label it as a query. Yeah, this I'm label it as a query. Now, so here I'm going to give a file underscore path, and let's suppose file is rag content.txt. So this is basically a file for me. This is basically a file for me. Now, so what it will do, so it will try to, right? So it will try to go to a file and it will try to read a data. So here, path. So I have to do an import to get a path variable, path function. So from path lib, import path. Yeah. So here what it will do, so it will try to read a data. So I can try to read a data with open command as well. I can try to even use this one to read the data path, and inside that we can try to provide a file path, and I can say that load basically, or there is a function called as read underscore text, read text. So this is going to read a data. The path should be P capital. Yeah. So I'm trying to say that, okay, fine. So try to read a data out of this one. So it will try to read a data, and I'm going to name it as a context, by the way. Yeah, I'm going to name it as a context. Now, so here, once we are able to read data, and I'm just trying to name it as a context, by the way. So let's try to return the output of this function. So what this function will try to return? So this function will try to return query is equals to query. So whatever input that anyone is going to give, and then this function is going to return technically a context. Yeah, context context. So these two things this function is going to return. Context is nothing but a data which is coming from the, and I can say that till 3000 is the limit, or 30,000 is a limit. So here this is going to return the query. So this is going to return the query, by the way. I'm just trying to pass a state. A state means because the entire graph is a stateful process, right? So it knows that, okay, fine. So what is happening where? So whatever state it is going to come, it will try to take input. So let's suppose if I'm trying to provide the input here, right? So at this state, I'm going to provide the input over here. It will try to take the input, and based on the and that will become a query, right? That will become a query, and it will go to my file as well, and it will try to read the data, and that I'm calling as a context. So query and context. So now if I'll talk about this mode, so this is going to give me a return of what? Query and context. Query is coming from user input, right? Or I can say user input, and context is coming from where? So file dump. I can just name it as a file dump. So whatever file that we have given, so from there we are getting the context. Now this is the state. This is one of the state that we can say. So this is a independent isolated function as of now. I have not attached this function to anywhere. So just execute it and leave it. So this is one of the independent function I have created. Yeah, independent function I have created. Now, so I have to basically add this function as a node inside a graph. So this is my graph object, right? So I can call it in this way, graph, the graph object that I have already created. So graph dot add, and here, so you will be able to see a multiple options. So add AI node, add condition node, conditional edge, conditional load, add a functional node. So I believe now you will be able to guess that what kind of a node I'm trying to add. So basically this is the node which will take a user input. It will try to like consider the user input, plus it will go and check the file. It will try to read the data from the file, and it will try to return just that much, right? So now if I have to add this as a node, so obviously it's a functional node. It's not an AI node. So functional node wise, I can try to give a name that, okay, extraction and query, extraction underscore and underscore query, just for the clarity. And this node is going to call what? So this node is going to call research node function, which is trying to extract the data, and it is trying to like take the query. That's it. Yeah. And I have just attached this function to this one. So this is how I'm using this function. Now one element is added inside the graph. So added a function node. Now if I'll go and check graph graph dot get graph structure, you will be able to find out that one node is being added. Yeah. One node is being added. And what is the name I have given? I have given this name. You can try to give any name that you want. But yeah, one node is added. Do we have any AI node? No. Do we have any kind of a edge? No. Do we have any conditional edge? No. Entry point, have I set entry point? None. Finish point? None. As of now, I have just added the node. Simple. One node I have been added. Now, so one node, this node I have already added, let's suppose. So one node is done. One node is done. So node one, let's suppose. Okay, cool. Now the next node I can try to create for maybe a separate task. So here graph dot add, this time I'm going to create an AI node, let's suppose. AI node means it will be having a LLM access. And for an AI node, I can try to give a name that, okay, so this node I'm going to call it as synthesizer, synthesizer, synthesizer. I'm just giving a name to it. You can try to like do whatever you want. And here, so it is going to take basically a prompt, let's suppose. So It's a LLM node, right? So obviously I can write a prompt. So PROMPT, prompt template. So prompt template is equal to what? So prompt template is equal to, I can try to write over here, summarize the following document input that I have given to you in very, very detail, right? So what document input, by the way, I'm going to give? So I'm going to give basically a context. Yeah, context. Now from where this context is coming, by the way, /n, let's do it in this way. So context. So what this context, from where this context will come? Obviously this context will come from here, because this is going to return me context, right? And what is context technically? Context is nothing but the data which is available over here. So I'm saying that okay, so whatever like data that we are able to get inside the context, do one thing, summarize it. Maybe there is 100 lines, thousands of lines inside my document. I don't want to, use that 100 and 1000 line. I just wanted to use like a summary of it. Simple, right? Summary of it. I would like to use it for the further process. So, okay, synthesizer and this context. So basically it is going to take this context. So now I have another node number two, and this is going to basically do what? So whatever data input, I have not connected yet, but yeah, I'll connect in some time. But yes, what I'm assuming that node number 2, whatever data it is trying to read from the file, it will try to summarize it. Simple. So, okay, this will do automatically. Now execute it for now. And now if you are going to check graph.get graph structure, you will be able to find out two nodes. One is this AI node synthesizer. This is the very first AI node I have created. This node is technically a function node. Yeah. So two different kind of a node I'm dealing with as of now. Fine. So this is also done. Now, just try to like create one more function, right? One more function. It's a classified topics. So state context, just try to like keep all the context into a lower, and if LLM in text, then LLM workflow, RAG in text, RAG pipeline. Means I'm just trying to do the classification of whatever data which I'm trying to read from the context, which is available at the particular state, right? It's a state process, right? A stateful process. So whatever is available at the particular state, just try to classify it. Okay. So this is another independent function, and I can try to like maybe use this add function node, right? Add a function node, and here, so this will be classifier, and which will classify topic function. So this is another node I have added. Now, if you are going to check, so get graph structure, you will be able to find out three node now. This. Out of three, one is a AI node and two is a functional node, right? Two is a functional node. Very simple. Okay, fine. So this we are able to add. Now the fourth node. So till this point, I'm able to create a third node number 3. So which will try to do classification, by the way. Okay, so 1, 2, 3, I'm able to create 2 functional and 1 AI node so far. Now I can try to call graph dot add AI node, and I'm going to give this node as a name as a finalizer, finalizr, finalizer. So which will finalize the entire things. So here finalizer will take a prompt template. Now what kind of a prompt I'm going to give basically? So I'm trying to give, like, let's suppose this kind of a prompt. So I'm saying that do one thing, try to take query, try to take topics, which is coming from here, from this node, try to take the context, which is coming from like the very first function, right? So use query in topics, context summary, basically context, answer the clearly using all the context above. So this is going to finalize, and this is going to give me the final output basically. Now if I'm going to show you graph dot get graph structure, sorry, my bad. So get graph structure, you will be able to find out 4 node now, right? 4 node now. So technically we have a 4 node over here. So N4. So in a graph, we are able to create basically 4 node. So 4 node is done. Now we have to set which one is going to be the entry point, which one is going to be the finish point basically, and how all of these 4 node will be connected amongst each other. So how I can set it? Let's do it then. So graph dot, you can call set entry point first of all. So who is going to my entry point? So let's suppose I'm trying to give the very first one. You can try to give anyone as an entry point. That's up to you, right? That's up to you. So extraction and query as an entry point. So I'm saying that okay, so try to consider extraction and query node. That was the node name. So that as an entry point. Set, done, right? Now graph 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 dot add add edge. Yeah, edge means now node 1. This was the node 1, by the way. Yeah, this one basically a node 1. Now so add edge. Yes, add edge. So here we can try to add a edge from this to the next one. I'm just trying to draw the line. So here add edge wise, let's suppose this is my node. This is my node, and I'm going to add a edge from this node to the next one. So maybe my next one was synthesizer. So to a synthesizer, I will try to add the edge. Add the edge. Now what it will do, by the way. So let me add edge, extraction and query to the synthesizer. This is what it has done. It simply means that this was the extraction node. This was the synthesizer node. I have added a edge from here to here. This is something which I have done. This is the something called as edge. And this I have labeled it as an entry point. Entry point. So I have my entry point with node 1, and then I have a edge over here. EDGE. This is how these two are connected, by the way. So I have connected. Now, so next one, graph dot add. Again, I can try to call add edge, right? So this time I'll connect synthesizer with the next one. I can connect in any order, that depends upon me, by the way. So synthesizer, and I'm going to add synthesizer to the classifier node. So which is going to classify the entire topic. Synthesizer to a classifier node. So again, add edge. Now what will happen? See, synthesizer to classifier. So simple, node 2 to node 3. Node 2 was synthesizer, node 3 was classifier. So node 2 to node 3. So again, we have created the edge. We have connected. So this. So I'm just trying to add or connect the graphs, by the way. Okay, now, so again, we can try to call graph dot add edge over here, right? Add edge over here. And this time, so I'm going to add a edge from classifier to the finalizer, the final one, right? The final one that I've created. So this is the name. This was the name. So I just have to give a node name, finalizer. Okay, fine. Classifier to finalizer. It simply means that now I have connected even this to this. Simple, right? This to this in this direction. I have connected. Now, once this entire things is done, I have to do graph dot set finish point. Entry point I have already set, and finish point. So finish point, whatever result which I will get from the finalizer, I'm considering that as a finish point. Again, not hard and fast. You can try to set any node as a finish point. That's up to you, right? So finish point. So okay, this is also done. Now, if I'm going to show you graph dot get graph structure, right? So see, I had a 4 node. Out of that, 2 node is AI node. I have a edges. So basically, this to this one edge, this to this one edge, this to this one edge, right? This to this one edge. So even edge I'm able to create 1, 2, 3. We had 3 edges, right? We had 3 edges. Then we have basically an entry point and we have a finish point. So now everything I'm able to see inside my graph structure. Simple, right? So this is the graph structure I have created, and every node is trying to do something, right? Every node is trying to do basically something out of it. That looks cool. Now how I will be able to execute it, because graph creation is done. I am able to give an LLM access to my model. All these things are done. So how I will be able to run it? So maybe if I have to run it, so maybe I can try to call graph.run, right? Graph.run. And whenever I'm trying to run a graph, so obviously I have to give an input, right? Because that was the entry point. I had to give the input, right? I had to give the input, by the way. So from the state, it will take the input. So input was the key. So I have to give an input value. So means query basically. So input input input, right? So I can try to give an input from a UI. I can try to give an input over here. That's up to me, right? That's up to me, by the way. So here I can try to write maybe a query that how can I can try to write a query that how can the LangGraph and Euri be used to build a multi-agent RAG system. Fine. So this is my query. Now, once I'm going to give a query, it will go to the entry point. So I'm giving my input. It will go to this one. What this will do, this will try to take the input as well as it will try to extract the data. Extract the data from the document which I had. For that, I have already given the access. I can give access of hundreds of other documents as well. It will try to create the context. Then this is going to do the summarization. Now this is going to divide my topic, right? Divide my topic into a different classes basically. And then finally it is going to use the AI LLMs and then it is going to give me the result. This is what I have built. So here just execute it and graph compiled successfully. Update. So extraction and query how LangGraph this one context. So context it is trying to pick from open source Python framework building the stateful. So this is trying to pick it from this one. Now if I have to do the complete analysis, right? So maybe I can try to copy this one and I can try to paste it over here, right? So many things it has done, by the way. So many things it has done. So many things, right? So here, if you have to you have given this particular query, it is trying to extract the context. It is trying to synthesize the output, synthesize raw responses, topic LLM workflow. Yeah, so topic was LLM workflow, by the way. So it is able to do the classification, finalize error, set object has no attribute, format, error handle, false. Build a multi-agent context, this. There is some issue I can see. LangGraph is open source for deploying a Python designed for specifically. The too long output. The framework also support the streaming output and the real-time inferences by application, lightweight. Okay, so finalize error, set object has no attribute. So there is a minor error which I can see over here. Let me fix that part. It's just a formatting error. So graph.run. This is basically a key value that looks good. Maybe let me save it as a result and print it. A final output, and basically that is a result. So let's see. So it's calling all the node one by one automatically. Yeah, so final output basically LangGraph. Yeah, so I'm able to see the final output. See, so context was this one, and yeah, so I can see the output. I can see the output which is not available in my system. It is trying to use the LLMs clearly, and I can see that it is trying to give me the output, synthesizer output, and here. So yes, all the output it is trying to give. So here we are able to create a graph. Technically, this particular graph we are able to create. Now, if I'll talk about the agent, so all of this node is working as a agent, So agent 1, node 1, agent 2, node 2, agent 3, node 3, agent 4, node 4. And as we can see that it's not like I'm trying to use a AI every time. So sometime I'm trying to use my own function which I have written, and sometime I'm trying to use basically a LLMs, right? So AI node. So this is how with the help of AI, with the help of LangGraph, I'm able to create a multiple agent. I'm able to connect it all together. I'm even able to perform a little bit of RAG operation, not much, not a hard-coded RAG. So basically, RAG retrieval wise, I'm just trying to I'm not using a vector over here. I'm just trying to store the data, and directly I'm trying to use that particular data while reading the data. So we have basically a finalizer agent, we have basically a classifier agent, we have basically a synthesizer agent, and we have basically a extractor and input taker agent, right? So these are the agent that we are able to create, which is a goal specific agent, which will be able to take a decision automatically that what we are supposed to do in which particular state. And yeah, so all of these agents are connected, and all of these agents are trying to work together. So this is all about a multiple agent, guys. So if we can create this, we can create another thousands of other agents as well. Depends upon my task, depends upon the things which I'm trying to build or I'm trying to perform, which I'm going to show you a lot of times, many times, by the way. Yeah. So with that, thank you so much, everyone. Take care. Hope all of you are enjoying your life and lecture both. With that, thank you so much. Take care, everyone.